हेलो एवरीवन। आज हम देखेंगे GD&T। GD&T का फर्स्ट सेशन है इंट्रोडक्शन टू ज्योमेट्रिक डायमेंशनिंग एंड टॉलरेंसिंग। Geometric dimensioning and tolerancing. Drawing is the communicating language between the product designer and the manufacturing engineer. It is the standard set of the symbols. It is the standard set of symbols, rules, and vocabulary to clearly define the drawings. It is a communication tool to help the engineers of different departments understand the product design. नेक्स्ट चैप्टर हम देखेंगे कि इन GD&T में जो मशीनिंग फ्लो चार्ट होता है वो किस तरह होता है. Let us consider the steps involved in creating a mechanical device to solve a given problem. First step is conceptual development or product design, the designing stage. Second is draft or detail the plan for each part in the drawing stage. Then the individual parts are machined. Next, we lay out the assemble. Finally, the device is assembled. In machining flowchart, there हमारे पास 5 steps available होते हैं. First, design. Second, drawing. Third, machining. And then assembly. And fifth one is completion. नेक्स्ट टॉपिक हम देखेंगे इस सेशन में कि नेसेसिटी ऑफ डायमेंशनल टॉलरेंस एक्चुअल में क्या होता है. हमें डायमेंशनल टॉलरेंस की ज़रूरत क्यों पड़ती है. इट इज़ ऑलमोस्ट impossible and sometimes uneconomical to maintain the strict degree of accuracy due to inevitable accuracy of manufacturing method. Due to interchangeability or mass production, it is impossible for an operator to make perfect settings. In settings up machine, that is, in adjusting the tool and workpiece on the machine, some errors are likely to creep in. To accommodate things, this is normal to display measurement with a plus or minus tolerance which allows for some margin of above errors. Usually the dimensional tolerance is decided at the design stage and a machinist must take care to apply the required dimensional tolerance and ensure that discrepancies are not introduced as a result of pure workmanship of measuring techniques. The tolerance is a compromise between accuracy required for proper functioning and the ability to economically produce this accuracy. नेक्स्ट टॉपिक की तरफ हम बढ़ते हैं. टॉलरेंस डायमेंशन. Tolerance is the total amount that a specific dimension is permitted to vary. It is difference between the maximum and the minimum limit for the dimension. Tolerance may be specified in 3 places. First is directly on with the specified dimension. Second, in general note. Third, in a title block. For example, a dimension given as 1.625 plus or minus 0.002 means that the manufactured part may be 1.627 or 1.623 or anywhere between this limit dimensions. Here, more types of tolerancing dimensions are available. First is unilateral tolerance. Unilateral tolerance means is allowed to only one direction from the nominal dimension. For example, if a dimension is given as 50 mm plus 0.1 mm or minus 0 mm, it means the actual dimension can vary between 50 mm and 50.1 mm, but cannot be less than 50 mm. Next type is bilateral tolerance. Bilateral tolerance is allowed in both directions from nominal dimension. For example, a dimension specified as 50 mm plus or minus 0.1 mm means the actual dimensions can vary between 49.9 mm and 50.1 mm. नेक्स्ट थिंग जो हम देखेंगे कि वाई टॉलरेंस डायमेंशन मैटर हमें टॉलरेंस डायमेंशन की इतनी अ, हमारे डिजाइनिंग्स पे क्या मैटर करता है फर्स्ट point is fit and function ensure that parts will be fit together and function properly within the design assembly. Second point is cost control. It helps in managing manufacturing cost by specifying reasonable limits of variation. And third point is quality assurance. Facilitates quality control by defining the acceptable range of dimensions for manufactured part. अब हम स्क्रीन पे देखेंगे कि हमको टॉलरेंस अगर एक्सप्रेस करना है तो हमारे पास उनके जो टाइप्स अवेलेबल हैं उन्हें हम किस तरह एक्सप्रेस करते हैं फर्स्ट इज इक्वल बायलैटरल टॉलरेंस 1.00 plus or minus 0.5. This is the equal bilateral tolerance. Second is bilateral tolerance 1.00 plus 0.05 or minus 0.02. Third is unilateral plus tolerance 1.00 plus 0.05 minus 0.00. This is only unilateral plus tolerance. Fourth one is unilateral minus tolerance 1.00 plus 0.00 or minus 0.02. This is unilateral minus tolerance. Second thing is plus limit to line is 1.05 to 0.98. Minus limit two lines 0.98 to 1.05. And next one is plus limits one line 1.05 minus 0.98 or minus limit one line 0.98 minus 1.05. This is the actual difference between the basic size in unilateral and bilateral tolerances. नेक्स्ट पॉइंट हम देखेंगे वे ऑफ एक्सप्रेसिंग टॉलरेंस हम टॉलरेंस को मल्टीपल वेज में एक्सप्रेस कर सकते हैं फर्स्ट हम एक्सप्रेस कर सकते हैं इन न्यूमेरिकल वैल्यूज न्यूमेरिकल वैल्यूज डायरेक्टली स्टेट्स द परमिसिबल वेरिएशन फ्रॉम नॉमिनल डायमेंशन इसका फॉर्मेट कुछ ऐसा दिया जाता है कि nominal dimension followed by a tolerance value. For example, 100 mm plus or minus 0.05 mm indicates that the actual dimension can range from 99.95 mm to 100.05 mm. नेक्स्ट इज जो हम टॉलरेंस को एक्सप्रेस करते हैं इन सिंबल्स में Symbols may also define utilizes standardized symbols to denote tolerances related to geometric features and their relationships. इसका फॉर्मेट हमें कुछ इस तरह दिखता है Symbols are used with feature control frame to specify tolerances for attributes such as position, concentricity, and angularity. For example, position symbolized by a circle with a cross inside, specifying tolerance around a reference point. Concentricity, symbolized by concentric circle, indicating how well a feature aligns with a central axis. Next is angularity, response by an angle symbol defining tolerances related to angular deviations. नेक्स्ट इज हम एक्सप्रेस करते हैं टॉलरेंस को रेंजेस में. रेंजेस प्रोवाइड्स अ मिनिमम and maximum value of a dimension, outlining the acceptable limit of variation. उस रेंज का फॉर्मेट हम कुछ इस तरह यूज करते हैं कि मिनिमम एंड मैक्सिमम लिमिट्स के बीच में. For example, 50 mm to 50.2 mm specifies that the dimension can vary from 50 mm to 50.2 mm. Next topic is in tolerances versus manufacturing process. The choice of tolerances depend on the manufacturing process used. Different processes have different capabilities for achieving precise tolerances. Process like grinding or EDM can achieve tighter tolerance compared to process like casting or forging. नेक्स्ट टॉपिक है हमारा फर्स्ट सेशन में डेविएशंस. Deviation refers to the difference between the actual dimension of a part and its nominal design dimension. For example, deviations में हम दो टाइप यूज करते हैं. First type is positive deviations and second type is negative deviations. In positive deviations, actual dimension is larger than nominal dimension, and in negative deviations, actual dimensions is smaller than nominal dimension. हम स्क्रीन में इस स्केच में डेविएशंस को डिटेल में देख सकते हैं. This is the upper deviations. This is the lower deviation. This also as positive deviations, and this is also called as negative deviations. Next point की तरफ हम चलते हैं. Basic whole system. In the basic whole system, the whole is treated as a primary data feature, and its dimensions are held to tighter tolerance than the shaft. Common in design, where precision in the whole size is critical to ensure proper fit. Next point is basic shaft system. In the basic shaft system, the shaft is considered the primary datum feature, and its dimensions are controlled more strictly than the whole. Used when the precise control, basic shaft system used when precise control over the shaft dimensions is required for performance or assembly. IT grades. Next topic is IT grade. International tolerance grade. IT grades provide a standardized method for specifying tolerance limits based on the nominal dimension of the part. Grade is the range from IT01 very high, very tight tolerance to IT16 loose tolerance. We also show on the screen IT grades. IT grades IT grades in lapping is 3, 4, 2, 3, 4, 5 is from IT grade. Honing is the 3, 4, 5. Super finishing, cylindrical grinding, diamond turning, plant grinding, broaching, reaming, boring, turning, sewing, milling, planning, shaping, extruding, cold rolling drawing, drilling, die casting, forging, stand casting, hot rolling or flame cutting. This, this all type of procedures have IT grades. Next topic is fits between mating parts. Fits describe the relationship between two mating parts and are categorized as हम फिट्स को इस तरह कैटेगराइज करते हैं कि फर्स्ट इज क्लियरेंस फिट, सेकेंड इज इंटरफेरेंस फिट, थर्ड इज ट्रांजिशन फिट. Clearance fit provide space between parts. Interference fit provides parts are designed to fit tightly together. Transition fit allows for a small amount of both clearance and interference, ensures proper assembly and functions of components. Next topic है allowance. Allowance is the international difference between the maximum material limit of mating parts designed to ensure a specific fit. Allowance ensures that the part will fit together as intended by com- compensating for variation in dimension. Clearance. Clearance is the space between the two mating parts. It is a critical aspect of clearance fit. Clearance allows for movement, preventing binding, and accommodates thermal expansion. These concept, these concepts are fundamental in ensuring the accuracy and functionality of machine parts, impacting everything from design to production to final assembly. Thank you so much.